Hello! This is going to be fun. So after my last video, you can check it out here, about if you should do a PhD in Spain, I decided to show you the work I've been doing for the last 3 years, called MoviSound. At least that's the platform that combines everything I develop. And I'm speaking in English because I want this to be useful to other people. I need a job. So I'm sorry if my accent is weird. I'm doing my best here to trying to communicate in a different language. Yay! So first, showing the application architecture, I'll just have it on my iPad here, and I'll show you the image somewhere here. So the users connect to the front-end application through Caddy. As source, everything is secured. And then for the front-end, we have the SQLite database, as we are using Django. And then there we store the users, the audios, the generated reports, and everything related to the front-end content that we'll show to the user. Then every time the user uploads a new classroom audio, it's sent through Celery to a front-end worker, so it starts a new instance of the backend. The backend does not have direct access to the SQLite, and that's by design because these have to be decoupled. So we have an intermediate database that is MongoDB. So the front-end worker takes the audio from the SQLite to MongoDB, and now the backend can process the audio. In the backend, we start generating the transcription, extracting the audio features, applying the machine learning models developed through the PhD, and every single step is reported back to the frontend through the frontend consumer using Kafka. So the user can get real-time updates of what is being processed right now in the backend. Then we have an Olama instance running Gemma 4, if I recall correctly. It generates both a summary of the concepts spoken in the class using the transcription generated, and also gives some general guidelines based on the audio features we extracted during the backend process. Once everything is finished, the final results are stored again in MongoDB, and the frontend consumer is in charge of storing those data directly in SQLite again, so the user can access it through the frontend. So the reason I have two databases, SQLite for the frontend and MongoDB for the backend, is because they are decoupled services. The backend can live without the frontend I developed, because we had to work with other projects in the university that didn't use our frontend, so we need like a way for the backend to access the audios in a database and store back the results. So now that we have finished with the architecture, let me show you the app. Okay, so here we are in the platform. The first thing the user will see once logged in is their already uploaded audios. In this specific case, I have example 2 and example in Spanish, and also a folder called Fundamentos. So the thing is that you can search or organize this through folders, through tags, or even by date. Like, for example, I'm searching for 2026, so we are already in 2026, so everything is for that date. You can search by any metadata available. Which metadata is available? Well, when you click on Upload Audio here on the top right, you can see that you can set a new title, for example, video test, and where you want it to be saved. By default is the folder that you are already located when you hit the upload button, and also which file, obviously the most important part. In this case, I'm going to upload a video, not even an audio, a video. The recording date, some tags if you want to search by them or organize them in any way, and some comments or description if you want to add, for example, what was the session about. So once you hit start processing, the file will be uploaded to the server. In this case, I have a very slow speed connection, and it's a 1.3 gigabyte file, so it will take a little while. But once uploaded, it's going to be saved in the SQLite database we discussed earlier, and then it will call the front-end worker to start a new instance of the backend. Okay, so now the audio is uploaded, and we can see that it's starting. This is the messages that will be changed according to the current process, and this is updated through Kafka. So, for example, if we give it a little more time, it will change to something like starting AI engine, there it is. And then we'll have the waiting for a new GPU available, because I have a very limited amount of GPUs. In fact, I have one GPU, so I have to make sure that that GPU, there it is available to work. So yeah, I cannot have multiple pipelines at the same time because I don't have enough memory. Instead of waiting for this, that it will take a few minutes, I will just show you another example that I have already prepared. So the first thing you see once you open a specific audio already processed is the player up left, and you can hear every minute of the class, also the metadata available for you that you can change if you want. And the first thing is the global features. So this is like a snapshot of what happened during the class. A general view, let's call it a general view. So for example, in this case, we see that the teacher spent about 55% of the time speaking, while the students only spoke for 26%, but that's actually quite good, 26% of the time that the students spend participating in class. That's actually a good result in this case. We have also the number of interventions, the ratio of interventions, and also the average duration for each intervention. In this case, for example, the teacher spent on average 3.8 seconds and the students 1.1 seconds. This is great, but I want to see the specific details in some parts of the class. So for that, we have the temporal features. In this case, the first one is the participation timeline. This is the same PSR feature we just saw, the participation, but along the time axis of the class. So we see for example, on the minute 10, the professor spends 47% of the time, but the student spends 52%. So we can see this for all of the available features. But also we have the classifications of teaching methodologies. So there is a model that can differentiate which teaching methodology among 3 different methods is used at each moment. So turning it on, we can see that the first quarter of the class was group work. This is where students join in small groups and solve a problem in common, talking with each other. That's why the students were talking more in this part of the class. And then there was a lecture. This label is lecture in English, where the teacher probably decided to solve the problem in the blackboard or just continue the class. And in the end, we can see a different level. This is the student response system. And this is when students use their phones to answer questions that are shown on the blackboard, like using platforms like Kahoot or WooClap. So this is where everyone is competing against each other. Then we have the transcription for the class. So we can see that I'm not the one who's speaking in this audio. This is a sample audio, but by default, the main speaker, the speaker that spends most of the time, is assumed to be the teacher. And in this case, the teacher is usually the one uploading the audio, so it's already labeled as the user. And we can see every different speaker during the class, but we had some issues because we only used one microphone for everyone in class, so people who was more than 3 meters away from the microphone couldn't be properly captured. Even though we know they were students speaking because we have the embeddings of their voices, but we do not identify them. So we know they are not the teacher, so we assume they are students. We also have a specific part regarding the student response system where we label each intervention from the teacher, so we can see in which interventions he's spending more time on, if he's spending more time explaining the questions or answering or just moving fast through questions. And here we have an underdeveloped part because it was much bigger before we had to cut it a bit. It uses LLMs for 2 main purposes. The first one is to generate a summary about the contents of the class, what was spoken in class. For example, in this case, the class was about computer networks and what concepts of computer networks we discussed during the class. And also some general feedback, some general guidelines for the teacher. We cannot assess properly what is good or bad teaching because that will mean that there is a perfect teacher, and that's not true. So we just give some general guidelines based only on the audio features we provided in the beginning. And at some time we also have a chatbot that you can talk to. This chatbot had the information that we extracted here, so you can discuss with him what could be improved, why some things that you tried didn't work or whatever. But we needed to work a little more on that, and my PhD was finishing, so we just had to leave it out. And in the end, we have a PDF, so if you want to download it and print it, there is a chance to do it. I don't know. Because this was like the preliminary version of all this platform. So yeah, this is the platform I developed for my PhD. I'm sorry if my accent was terrible. I'm trying my best here, speaking in English. So yeah, if you have any questions, just ask in the comments and I'll happily address them. See ya!